This video is going to give you some assistance with the final calculations on the post-lab for chromatography week 2, specifically number 3 and number 4. So backing up a little bit, what you're going to need to have to do these calculations is this final item right here under the graphs section, where you have to calculate the concentration of each unknown component, each unknown dye, based on the information from the scatter plot. For number 3, what you're going to calculate is the original concentration of each dye in the Green River. And then number 4, you're essentially going to figure out whether or not the amount of dye that's in the river is lethal to the fish. So let's start with number 3. Here we have number 3. And what I'm going to use is a sample value for the concentration of methyl red. So this calculation is going to be for methyl red, but you also have to do it for malachite green. The number I'm going to use as a sample value is 2.5 times 10 to the minus 5 moles per liter, N. You want to use your own value here that you got from your scatter plot. Now, when you received the sample site for sample, you were told that it was concentrated, and it was concentrated by a factor of 100,000. So we originally the concentration got multiplied by 100,000. So to undo that, we have to do the opposite, which is division by 100,000. So divided by 100,000. And then when you were doing your column chromatography, you were diluting your sample by adding that acetone ethanol mixture to it to push it through the column. And so you diluted it by a factor of about 20. So you divided the concentration by 20. So to undo that, we have to do the opposite of division, which is multiplication by 20. So what I get for my sample number is 5 times 10 to the minus 9. So N. And remember, you're also going to need to do this for the malachite green, but what I would suggest is that you go through the calculation for one dye, for number 3 and number 4, and then you come all the way back here and then do it for the second dye. Okay, now we have number 4. Let me bring it over here. Okay, so I'm just going to read through this problem because it gives us some numbers and it tells us what to calculate. So it says that if a 2-kilogram fish filters 100 liters of water a day, what's the maximum mass of each dye the fish encounters? Consider the LD50 value. Refer to your pre-lab assignment from week 1 for each dye and calculate the number of days it would take for the fish to be exposed to a lethal dose, and compare this to the average age of a bass. Explain any assumptions you made for these calculations. And we're going to make quite a few assumptions in these calculations. One of them is the fact that we're going to assume that the fish has mass of 2 kilograms. We're going to assume that the fish is exposed to 100 liters of river water in terms of it using the water to breathe in and get oxygen. LD50, if you remember, is the dose that it takes to kill a population of 50% of the organisms that are exposed to this dye. It's the concentration of it. And so essentially what we're figuring out is whether the amount of dye in the water sample is going to be lethal to the fish. So what we've got to look up is the LD50 value for the dyes. So for methyl red, quick Google search tells me that it didn't give me any results for fish per se, but it did give us a LD50 value for rats, so we're going to have to use that. So the lethal dose here is 5,000 milligrams of methyl red per kilogram of body mass. So let's bring that over here. So we're going to say 5,000 milligrams of methyl red per kilogram of body mass. And so we can take this unit and convert it into grams per kilogram. So that equals 5 grams per kilogram of body mass. We know that the fish has a mass of 2 kilograms. So the lethal dose of methyl red is going to be 10 grams, and we'll call this the lethal dose for our 2 kilogram fish. So if the fish gets exposed to 10 grams of methyl red, it will die. The other information that we're going to need is, because our concentration is in terms of moles per liter, we need to know the molar mass of methyl red. So the molar mass of methyl red, it's a pretty big molecule, so it has a pretty big molar mass, 269.3 grams per 1 mole of methyl red. Finally, we need to talk about this term right here, bioaccumulation. This term has to do with whether a toxin, when an organism gets exposed to it, whether or not it remains in the organism or if it comes in and then gets excreted. We're going to make the assumption, for simplicity, that the methyl red and the malachite green both do bioaccumulate. So what that means is that once the fish takes in 1 gram of methyl red, that it stays in there. It doesn't excrete it out. So it gets in and it stays there. And again, this is just for simplicity. Looking up the average age of a bass, the Google search told me that it's around 16 years. So I'm going to use that. If you get a different value, that you can use that too. But this is what I've got. 16 years. All right, so to do this, we need to do 2 separate calculations. So let's go up here a little bit, and we're going to be pulling numbers that we've written up here and also the concentration that we calculated. And that's actually the first step, is the fact that the concentration of methyl red in the water is 5 times 10 to the minus 9. Again, you would want to use your own value for this, but that's what I got using my sample value. And so the first calculation is going to be how much methyl red a fish gets exposed to per day. So exposure per day And in terms of amount, we're going to quantify it in terms of grams. So essentially what we're going to get here is grams per day. All right, so the starting point is that concentration that I've got to look back at again because I forgot it. 5 times 10 to the minus 9. So 5 times 10 to the minus 9 moles of methyl red per liter of water. And all of this is over the course of 1 day. All right, so the first step is to see how much it gets exposed to per day. So earlier we said that the fish takes in 100 liters of water. So this number here is for every 1 liter of water. So what we're going to have to do is multiply it by 100 liters. And so you can see that if we have liters down here and liters up above here, that the liters are going to cancel. And so what we get is 5 times 10, times, that is a little messed up looking, 10 to the minus 7 moles of methyl red per 1 day. Now the lethal dose, the LD50, is in terms of grams, so we've got to take these moles and then convert to grams. We know the molar mass of methyl red is 269.3 grams, so that's the next step, is to convert moles to grams. So 269.3 grams in 1 mole of methyl red. So you can see that moles of methyl red is going to cancel. We're going to be left with grams on the top and then per day on the bottom. Okay, what we get on the calculator is 1.35 times 10 to the minus 4, so a very small number of grams per day, but we have to factor in the lifespan of fish. So we have 1.35 grams, 10 to the minus 4 grams for every day the fish is alive. So that brings us to the second calculation, where we have to calculate the amount of time that it takes to reach the deadly dose. So time to reach deadly dose. All right. The starting point is going to be the number that we just calculated, which is our 1.35 10 to the minus 4 grams per day. Again, your value is going to be different. Grams per 1 day. Again, this is methyl red. All right. So what we know from earlier is we know that the lethal dose of methyl red is 10 grams. So that's our starting point. So we know that if it gets exposed to 10 grams that it will be lethal. So we can take this number here and use it to calculate the number of days. The only thing is that in order to get our units to cancel in the way we want, we have to take this fraction and flip it around. So I'm going to do that right down here. So I'm going to say on the top we have 1 day, and on the bottom we have our mass. Grams. Okay, you can see now that grams is going to cancel, and we're left with days. Okay, so what we get is we're taking 10 and dividing it by a small number, so we're going to get a big number for an answer. So 7.43 times 10 to the 4th days. So it takes that long for the fish to get a lethal dose of methyl red. Now, we know that the lifespan of a fish is in terms of years. So what we've got to do is take this time in days and turn it into years, and then just compare the two numbers. So to convert it, we know that 1 year is 365 days. And so what we get is quite a long time, 203 years to reach a lethal dose. And because 203 years is much, much, much larger than 16 years, we can therefore conclude that this is not going to be a lethal dose. Therefore, non-lethal. So the amount of methyl red in the Green River is at a non-lethal level. So that is how you do the calculations. Remember, I was using some sample numbers as I went through. So you want to use your own values when you do these calculations. And in addition, you have to go through the set of calculations for the methyl red and the malachite green separately. So you have to figure out whether or not the concentration of both dyes is lethal. That's it.